The success of the MER mission has demonstrated the tremendous value of mobile platforms in the scientific study of other planets. Yet the operation of such robotic planetary explorers remains an intensely complex and challenging process. The members of the Science Operations Working Group face strict time limits in which they must jointly select the next science targets and determine the specific science activities to be sent to the rover. NASA's Jet Propulsion Laboratory has developed the Science Operations on Planetary Surfaces Field Test in a Box, or SOOPS-FTB, software system to help address this challenge. SOOPS-FTB can be used by scientists and operations personnel to perform virtual science operations using a simulated rover and environment. While field tests in Mars-like areas have been utilized by the MER and MSL missions to great success, only one or at best a handful of tests can be performed because of the cost and time required. SOOPS-FTB can augment such field tests by allowing simulated operations to be easily conducted throughout the entire mission life cycle. In addition, SOOPS-FTB can be reconfigured to enable scientists to explore the operational impact of many engineering decisions, or simply to create a diverse set of different training scenarios. SOOPS-FTB is based on the integration of three primary components. Maestro is the ground systems tool, used by scientists in the MER, MSL, and Phoenix missions to browse the latest downlink data and to author new science activity plans. ROMS is a rover simulator capable of modeling full vehicle dynamics and ground interaction, including wheel slippage. The associated SimScape software package allows arbitrary terrains to be constructed or real terrain data to be imported. CLARAty is an object-oriented robotics software library used to implement much of the onboard rover software. CLARAty is flexible enough to enable operation of high-level capabilities on JPL's research rovers as well as simulated ROMS rovers. Thus, if desired, SOOPS-FTB capabilities could be exercised both in simulation and then on a real rover. Even before a particular mission has been identified, SOOPS-FTB can be used to explore how proposed or developing technology could be used operationally. Through hands-on exploration, scientists can both experience the benefit of the technology and also direct the technology developers toward the scientists' most critical needs. In 2006, a subset of the Onboard Autonomy Science Investigation System, OASIS, was incorporated into the SOOPS-FTB system. Then, scientists were invited to utilize those new capabilities in a simulated scenario.
The integration and the demonstration with SOOPS was considered very successful. We felt like we had successes in two particular areas. First, in integrating with the system and demonstrating to the scientists an operational scenario, we felt like they had a much better understanding of how our system worked and how they could better use the onboard science system to maximize the science return on the mission. In fact, one person even said that he had seen several OASIS presentations and he felt like by using the system in an operational scenario, he felt like he had an orders of magnitude better understanding of what OASIS could provide.
SOOPS-FTB can also be used to facilitate development of ground tools.
Maestro is one of the primary components of the SOOPS product and also one of the primary users of the SOOPS technology. The feedback that we get from scientist users and the experience we get running these science exercises with SOOPS generate new features, which often get infused into the products that we use to support the flight missions and projects. Two examples of these are image footprints and planning rover traverses and science activities in the context of orbital imagery.
As a mission develops and gets closer to flight, operational plans are developed based on factors such as the instrument suite, landing site, and communication capabilities. SOOPS-FTB can help by enabling scientists to explore a range of alternative operational strategies.
Okay, you've built your hardware, you've gotten your flight system together, you've launched, you've cruised, you've landed, you're there, you're ready. Now you got to figure out which rock to pick to investigate. And this is done typically by consensus. The use of a simulation tool like SOOPS enables you to try different combinations of, for example, short-range remote sensing examination of a rock, moving a rover over to a rock, and taking a non-contact investigation. Should you go straight to a rock, crack it open, and use resource-intensive analytical tools? It's important to learn how to triage the target analyte. SOOPS enables you to do this in an environment where you're not wasting resources, mass, power, data volume.
One advantage of simulated field tests is that the model of the spacecraft and its environment can be controlled and easily updated to reflect particular operational challenges. But neither simulated operations nor full-fledged field tests using a real rover can ever represent the full range of operational challenges that will arise during an actual mission. For this reason, the greatest benefit of using SOOPS-FTB to perform simulated field tests is that the participants will better learn how to reach consensus within the strict deadlines required during an actual mission.
Being a scientist in operations for a mission like the MER mission or MSL, where you need to do planning every day and react to what the rover in those cases has discovered on a particular day, this is an experience that most people haven't had and don't have the opportunity to have until the real live mission. A system like SOOPS can present that kind of experience to a fairly high degree fidelity to enable the scientist who is going to be in operations to really try it out and see what it's like to be involved in such a quick turnaround tactical operations.
SOOPS-FTB could also potentially play a role during the operations phase of a mission.
So I think another area where this technology could be very valuable is in helping operations teams to explore new regimes in the operations envelope of a given rover mission. For example, when you have anomalies like we've had on the MER rovers, where we have to drive backwards, or we have other constraints in terms of our instrumentation and mobility and manipulation. We can use a simulated environment like this to become familiar with that situation and to train operators or teams of operators in dealing with that. So I think this is another area that could benefit from having a readily available simulation environment like this.
SOOPS-FTB is a means for inexpensive and rapid execution of virtual field tests. By enabling simulated exercises to be conducted frequently throughout the mission lifecycle, SOOPS-FTB will improve 1. The development of new technologies, including science instruments, onboard software, and ground tools. 2. The efficiency and safety of nominal mission operations. 3. The training of operations personnel, both prior to EDL and mid-mission. 4. Help adapt ongoing mission operations to unforeseen environments or operating constraints.